Section 2, we're looking at finding areas of trapezoids, rhombuses, and kites. And again, there's just going to be a couple more formulas here that you're just going to have to memorize and understand how and when to use them given various figures when asked to find areas. So the first deal is obviously we have to go over these formulas. The first, the area of a trapezoid is 1/2 the product of the height and the sum of the lengths of the bases. So it's very similar to a triangle, okay, except you have 1/2 B1 plus B2 times your height. Okay, generally I'll write it like this. I'll write A equals 1/2 B1 plus B2 times H. Same difference, okay, it doesn't matter where the B1 plus B2 and the H are, because remember, multiplication is commutative. In other words, order does not matter when you're multiplying numbers. It's funny because, here's a story problem, and you have all this hoopla involved. It says to prevent beavers from damming a drainage pipe. Who cares about beavers damming a drainage pipe? Okay, the big idea is that you have a trapezoid fence, a trapezoid shaped fence here, and it says approximate the area enclosed by the fence. Well, identify your bases, B1, B2, and then identify your height. The biggest deal here is recognizing that the 8 root 2 is your height, not the 12. Okay, I know it's the height because it's perpendicular, and it's the distance between my two bases. That's what the height is in a parallelogram. Okay, so again, as soon as you know area of a trapezoid. So area of a trapezoid, you're saying A equals 1/2 B1 plus B2 times height. So A equals 1/2. B1 here we said was 8. B2 we said was 16. And the height is the 8 root 2. And so finally we're looking here, we have 1/2 of 24 times 8 root 2. And we're going to leave a radical here just for ease sake. Half of 24 is 12 times 8 root 2. 12 and 8 makes 96 square root 2. And then obviously it's area, so it's feet squared. Okay, so 96 square root 2 square feet would be the area of this trapezoid. Now as we look at the area of a rhombus, okay, first of all, do note that a rhombus is a special type of parallelogram, so depending on the information they give you, you may want to just use A equals BH. However, in a rhombus, you also have a secondary formula that also works for kites, and that is 1/2 the product of its diagonals, so 1/2 D1 times D2. Okay, same thing with the area of a kite. It's still 1/2 the product of diagonals, 1/2 D1 times D2. All right. So let's find the area of each polygon. This is clearly a rhombus. It's marked. Okay, all four sides congruent. That means it's a rhombus. You'll notice this piece here is 11, which makes this piece 11, and since this piece is 8, that makes that piece 8. Okay, so your two diagonals, okay, D1 here is 16, and D2 here is 22. And so the area is 1/2 D1 times D2. That's just 1/2 of 16 times 22. And so now I'm looking here, you can grab a calculator if you need to. Half of 16 is 8. 8 times 22 is, let's see, you're going to be 160 plus 16, which is 176 centimeters squared, since we're talking area. I apologize for the some of the goofy looking writing here. I don't know what's going on. It's I don't have good writing to begin with, but the smartboard's acting kind of goofy on me right now. Okay, so part B, find the area of the figure. First of all, you have to identify the figure itself. This figure happens to be a trapezoid, and we know that because since this guy here is perpendicular to both, that means that these two have to be parallel. Okay, and so area of a trapezoid, 1/2 B1 plus B2 times H. B1 is 9. B2 is 7, height is 4. So you have 1/2 of 16 times 4. Half of 16 is 8. 8 times 4 is 32 square feet would be your area. Okay. And then finally here, looking at part C, again, that's a rhombus. If that's 18, then that's 18. If that's 12, then that's 12, and so rhombus A equals 1/2 D1 D2. D1 here is 18 plus 18, which is 36. D2 is 1/2 of 12 and 12 is 24. Alright, and so I have half of 36 times 24. So let's see here, half of 36 is 18. I'm actually going to grab a calculator real quick. Let's see here. So I have 18 times 24. That's 432 square meters. Okay. And so again, you're just identifying the figure and then using the formula. It says one diagonal of a kite is 2 times as long as the other diagonal. What is the area of the area of the kite is 56.25. What are the lengths of diagonals? Well, A equals 1/2 D1 times D2. Plug in what you know. Okay, I know A is 56.25. They told me that. 1/2. I know the first diagonal is x. I know the second diagonal is 2x. Solve for what you don't. Find x. 56.25 equals 1/2. Let's see here. X times 2x is 2x squared. This 1/2 and this 2 are going to make 1, so they cancel. So yeah, 56.25 equals x squared. Square root both sides. So x equals, let's see here. X equals the square root of 56.25. Which is 7.5. So x is 7.5. So it says, what are the lengths of diagonals? Well, there's one diagonal. The other one is 2x, and 2x would be 2 times 7.5, which is just going to be 15. So the lengths of your diagonals would be 7.5 inches and 15 inches. Okay, it's important that you guys keep note of or keep track of the units here. Okay, oftentimes people forget units. Don't forget units. You have a diagram of your backyard. Again, doesn't matter if it's your backyard or not. Okay, each square represents a 3 by 3 meter square. Find the area of your backyard. Okay, well again, you look at the figure. This is clearly going to be a trapezoid. Since this is a horizontal line and that's a horizontal line, they have to be parallel. So those are my bases. So let's see here. I have 1, 2, 3, 4, 5, 6, 7 squares. Each one's 3, so that's 21. 1, 2, 3 squares. Each one's 3, so that's 9. 1, 2, 3, 4, 5. So the height's 15. And so again, trapezoid. 1/2 B1 plus B2 times height. B1 25. I'm sorry, not 25. 21. B2. I'm goofing this up. I'm sorry. 1/2 21 plus 9 times height 15. So you have 1/2 of 30 times 15. Half of 30 is 15. 15 times 15 is 225. 225. There we go. And again, units, meters, squared. Alright, so now that's just using the coordinate plane to help you find area. Alright, so this is another one very similar to the 2 examples ago, the kite problem, very similar. So I'm going to have you guys work through this one on your own, and then if there are any issues here, obviously bring those to class, and then we'll kind of summarize this one in class if needed. And then the last example is let's find the area of a rhombus with vertices M, N, P, Q. Okay, so really what it boils down to is you're going to have to do distance formula here. Okay, M, N, P, Q. You can graph it. You can do whatever you want, really. So what ends up happening here is if I graph this thing, M is 1, 2, 1, 2, 3, 4. So here's M. Q is, N is 5, 6. So 2, 3, 4, 5. 1, 2, 1, 2. Jeez, oh Pete's. So there's N. P is 8, 4. Keep going out this way. So 5, 6, 7, 8, 4. There's P. And then Q is 5, 2. So 5, 2. Now you'll notice you can use, and I actually misspoke earlier, because your two diagonals, here's one and here's another. Okay. The nice thing is, in this particular problem, the red diagonal, the y coordinate of m is 4. The y coordinate of p is also 4. So this is a horizontal line, and if you're going from 2 to 8, that means that you're going 6 units. So that whole length is 6. And then same thing with n and q. Okay, if you look at n, the x coordinate is 5. The x coordinate is 5, so that means this is a vertical line. If you're going from 6 to 2, that means this thing is 4. Okay, so now you go back to, it's a kite, I'm sorry, a rhombus, so you have a equals 1/2 d1 times d2. Diagonal 1 we just found out was 6, and diagonal 2 we found out was 4. Half of 6 is 3, 3 times 4 is 12, so you have 12 square units for your area. So again, just a different type of problem finding area using the coordinate plane. It's all the same stuff. Identify your figure, know what the formula is, plug into your formula, and simplify. Bring questions to class, and we'll go from there.